Welcome to this, which is the first science video of 2021, or actually the second, because the first one I had my microphone on mute, so we'll try this again. In this video, we're going to look at how to balance half equations. This is for Redox 2.7, which is an internal with 3 credits. So we'll look down at a resource sheet that you will be given. So here's the resource sheet here that has all of the half equations that you need to know, or that will be given to you in the assessment. So the assessment is that you will get there'll be 3 reactions that need to take place. The reactions will involve 2 of any of these species, and 1 will be oxidized and 1 will be reduced. So, I mean, an easy one, for example, could be magnesium if that was added to acid. So the hydrogen ion with an acid would react with it. Then the magnesium would be oxidized to magnesium 2 plus, and the hydrogen would be reduced. And so you would need to do that reaction and write the half equations for that reaction occurring. So in this video, we're going to show you how to balance half equations, which is part of the assessment that you would need to do. So there are 4 steps to balancing equations. So first of all, you need to balance the non-hydrogen and non-oxygen atoms. Secondly, you need to balance the oxygen atoms by adding water to the opposite side of the equation. Then you need to balance the hydrogen atoms by adding hydrogen ions to the opposite side of the equation. And then you balance the charges by adding electrons to the most positive side of the equation. So we'll go through and do one as an example. So I've got the hydrogen sulfite ion here. This is just taken from the resource sheet. So once you've gone through this tutorial, what you can do to practice is just take any of the half equations on the resource sheet and just write them down and balance them as some practice. So the first step is that we need to balance the non-oxygen and non-hydrogen atoms. So we've got a sulfur there and a sulfur there. So those are non-oxygen and non-hydrogen atoms. There's 1 of each, so there's nothing that we need to do to balance that. That's all good for us. The next step is that we need to balance the waters. We need to balance the oxygens by adding water. So here we've got 4 oxygens on this side of the reaction in the products, and in the reactants we've got 3 oxygens. So we need to make 4 oxygens over here. So to do that, we will add 1 water molecule. Adding 1 water molecule gives us that 1 extra oxygen atom. So we've now got 4 oxygen atoms there, 4 oxygen atoms there, so we're all good. The next step is that we need to balance the hydrogen atoms, and so if we've added water, we've inevitably added some hydrogen atoms and probably made it unbalanced. So here we've now got 2 hydrogen atoms plus the 1 hydrogen atom that came with the hydrogen sulfide. So to balance this, we will need to add 3 hydrogen ions on this side of the equation. So 3H plus. Excellent, and now we've balanced the hydrogen atoms. So that's step 3. We now need to, the final step is that we need to balance the charges so that we bring the most positive side down to the most negative side. And to do this, we can add electrons. So the first step with this is that we need to work out which side is the most positive. And this is something that can trip people up. And the reason that it can be a little bit tricky is because of just understanding what these symbols mean. So with chemistry symbols, we've got numbers all over the place, and depending on where they are, so we've got a big 3 there, small 3 there, and then some charges up the top right-hand side. Depending on where the numbers and symbols are in a chemistry formula, completely changes its meaning. So we need to have a good understanding of what the numbers mean according to where they are. So anytime you see a number or just a symbol on the top right-hand side of a chemistry formula, you can assume that there is a 1 behind any charge like that. So this hydrogen sulfite ion has a charge of 1 minus. We don't show the 1, but you just need to know it's there. And because there's no numbers behind this hydrogen sulfide ion, there's no big numbers there, that means we've only got 1 of them. So on this side of the equation, we just have 1 hydrogen sulfide ion, which has a charge of -1. The water molecule has got no numbers up the top right-hand side there, so that means it's got no charge. So on this side of the equation, the overall charge is -1. On this side of the equation, we've got this hydrogen ion that has a charge of +1. So again, we assume that there's a 1 there. And we have this sulfate ion that has a charge of 2 minus. The hydrogen ion, you can see that there's that big 3 there tells us that there's actually 3 of these hydrogen ions. So there's actually 3 positive charges overall there, and there's a 2 minus charge overall here. So on this side of the equation, we've got the 3 plus minus 2, so overall we have the charge of +1. And what we need to do is bring the most positive side down to the most negative side by adding electrons. And to do that, yeah, so we can add 2 electrons onto this side of the equation, and then we've brought it down to the more negative side. So we go +2 E minus on there. And then we've now taken this down from +1 to -1. So both sides are -1. So we've got our balanced equation. This is the balanced half equation here. The charges that I've put up the top, they're just for my own working. So you wouldn't include those in the final half equation. So that's it. That's how we balance the equation. To do some practice, just grab some of those half equations, the unbalanced ones off that formula sheet, and do your best. Thanks very much for watching. Like and subscribe for more chemistry videos.